Hello, in the previous video we have seen the basic boot process in the microcontroller. So in this video we will talk about the bootloader and then the memory organization in a microcontroller. So before going into further steps, there was one question that was asked to me, in the boot process you have mentioned that at the vector of address 0, we mentioned that there is a value that is mentioned which will be loaded to the stack top, and then the next address 4 will be having the program counter value, right? So now the question was, who tells or who loads this value to the vector addresses is the basic question. So now there are two things here. Advanced programmers do play around these values, but most of the application engineers do follow the default values that are saved in this. So we can say in one aspect it is mostly the microcontroller manufacturer who does this. So or there are guys who do write bootloaders at the beginning of the reset address, the vector address basically, and then take the execution to a next level. But definitely at some point of time it is required that you have to have the program counter value to know which step to execute, and then the stack point. So these two steps are necessary, but how the programmer does this is a his requirement and style of working. So most of the beginners don't tinker around these values, and they just try to use the default values. Now in this thing, we have used something called bootloaders. So most of the guys would be available. So we will create a separate video on that in the next videos. So this bootloaders basically could be said in simple terms, a small code which helps the microcontroller to read the data over different serial interfaces and in turn program the microcontroller. So major functionality of the bootloader is associated with programming the microcontroller with over serial interfaces. There could be other instructions or based on the requirements that could be written to this bootloader as well. Now while we talked about the boot process, in the next steps we will take an example of MSP432 to see how the memory is organized. Basically, if you see MSP432 microcontroller, this has a total memory space of 4 GB. So it's this is the total memory space, and in this 4 GB we have only 256 KB of the flash memory, right? So now while we go into the details later, so this 4 GB of memory space is divided into 8 zones, where each zone has 512 MB of memory. So this is how the basic memory is organized. So if you take a microcontroller, this is the first thing you need to know on how many zones it is divided into, and what is the memory of each zone. The next step. Now these 8 out of these 8 zones, one is code zone and SRAM zone, peripheral zone, and these are unused basically, and then debug trace peripherals, which we generally don't use. So now coming to these peripherals, SRAM and code, we use this code memory to load our application code. So now when a microcontroller user tries to compile his program and loads the hex file to the microcontroller, it is to this code zone where the program gets loaded. Now this code zone is again divided into different sections. One is flash memory region, second one is reserved, other one is called the SRAM region, and there is one more region called the ROM region. So what are all these? Is this flash memory is the region where inside this code memory we load the final program. So this is what 256 KB or whatever the microcontroller claims to be the flash memory. And then this SRAM region, as we said, there is a special SRAM region, and in addition in the code memory as well there is a SRAM region. While both are alias, that's like you have almost the same data across these regions. This SRAM particularly is used for our instructions and then the variables. And then this ROM region will have all the MSP432 driver libraries. So when you have your fresh microcontroller in your hand, you have this ROM region downloaded with the driver library, and based on which you call the respective header files into your program, and then write the application code and extensions to it. Now this is about the code memory. In this code memory we have seen that there is flash, there is a SRAM, there is a ROM. Now coming to the flash memory, you can see here. So in this flash memory also there are again further subdivisions, which is called main memory and the information memory. So this main memory and information memory, they have the same space. Again they can have different like it can load the code as we mentioned. Now this, as we mentioned, this flash memory is divided into sectors. Each sector is around 4 KB, and there are around 64 sectors total, comprising to 256 KB of flash. That means there is 256 KB of flash, where each flash is divided into sectors. Now if you see a flash memory organization, basically it is divided into sectors, and then few sectors combined together to form page, and these pages combined together to form blocks. So if you read any flash memory or just try to understand the organization of flash memory, or try to read a data sheet of any flash memory, you see these sector, page and block terminologies. So the lowest one which you can work in a flash memory is a sector, basically. So even in MSP432 also we have sectors. Now this again, so this is basically a typo here. It has been wrongly represented. It should be from here to here. So if you see this, this is basically the SRAM division. So again, SRAM, it has 64 KB of SRAM, the MSP432. SRAM basically can store an image of a code as well as the variables, because it has the fastest access. So in this SRAM region there are two regions. One is basic SRAM, and second one is the SRAM bitband alias. What is bitband alias? Is basically when you are trying to modify some registers, you can directly work at a bit level here, whereas here you have to work at a combined byte level. Here you can individually work at a bit level. So that is one feature which is called bitband alias region. This basically is the SRAM region, and this SRAM region is, as we mentioned, is mainly to store an image of code and the variables. Then If you see this is again, sorry, this is peripherals. So this is from here to here. Okay, so this peripheral region basically is used to control the peripherals, all the relevant data with respect to peripheral control would be done from this region. And again, this also has the bit band alias region. So these are the basic division of memories in MSP432. The main thing which we have to remember is, and which is commonly used for the freshers to understand, or the budding engineers to understand, is mainly the flash memory, which will be used to load the program. In that flash memory there are subregions, and which is the main memory is the one which will be used to store the exact code. And the entire memory map is the first thing the firmware engineers has to go through before writing their programs. So this in this we have particularly taken example of MSP432 to explain the different memory scenarios. Please write to us if you have any questions. Please let us know your comments on this video, and please like and subscribe our channel. Thank you.